While we are seeing about this, particularly this TCP, it's similar to the data link layer. We have a flow control mechanism and error control mechanism. While thinking about this flow control mechanism, we have seen with the sliding window concept. But error control, what are the reasons for that error? Error detecting, error correcting mechanism and all in the data link layer. But error control, what are the transport layer? What are the reasons it is responsible for now? Detecting and discarding corrupted packets. So the transport layer is responsible whether my packets are corrupted. What is meaning the corrupted now? We were saying the size now. This is my window size. So it will check always that particular size of bytes is arrived or not. If it is not that, automatically it will discard that packets. And sometimes packet will not be received from my sender side to receiver side. So all that reasons I can identify that it is an error. The next one is keeping track of lost and discarded packets and resending them. Okay, so sometimes we have a responsible that my packet will be lost. So I have to understand I didn't receive any acknowledgement. So I can understand that I have to retransmit my packets. Then recognizing duplicate packets, same packets I'm without the timeout period, I'm getting my packets now. Similarly, same packets are arriving now. That also I have to discard it. Then buffering out of order packets until the missing packets arrive. Until the missing packets arrive, I have to find out what is the order of sequence I'm getting. Okay, so error control mechanism, it is entirely different in the data link layer. There it will do all the checksum error and all, but it also do the checksum concept. But apart from the error control mechanism of transport layer is mainly it will checking with the packets, all packets are received or not, tracking the packets, avoiding the duplicate packets, and we have to find out whether any missing packets are arrived or not. All this mechanism is carried out by. We all know that while we are discussing about the data link layer, it is a node-to-node communication. While you're discussing about the network layer, it is host-to-host communication. While you're discussing about the transmission layer, it is only end-to-end communication. So end-to-end or process-to-process communication means that whether my error control mechanism is carried out in the transport layer, whether all my packets are received or not, all this will be how I'm responsible for your attendance, I'm maintaining them. The similar way, how many packets have been there, is there any misordered or duplicated or out of order packets are arrived or not. All this checking mechanism is important in the error control of transmit. That's why we are going on to the concept of retransmission. Retransmission mechanism, why we are, it is closely related with the error control mechanism. That's why the retransmission is, we are going to look up on that. Okay, what is retransmission? I told you the heart of the error control mechanism is the retransmission of segments. Okay, when a segment is sent, it is stored in a queue or it is acknowledged, whatever may be, the error control mechanism is a hot to check all this. When the retransmission or time expires, or when the sender receives 3 duplicates acknowledgement for the first segment in the queue, that segment is retransmitted. I think this may be quite complicated for you, but you also always understand that the timer is very, very important. How in your class I'm having 1 hour slot now, you are supposed to be come in the 1 hour. So the attendance always taken at the first 10 minutes. Okay, so you all understand that timer. Okay, it have a time warp concept. Within some 15 seconds or 500 milliseconds, my packet has to arrive. If it is not arrived, okay, at that time we will do retransmission, or else sometime without knowing that the receiver will keep on sending the acknowledgement that it received or not. So sometimes duplicate acknowledgement conditions also are there. So at that time also retransmission. So retransmission, that we can see to that whether my segment is arrived or the timer is expired, or I have seen that my duplicate acknowledgement I would have received without receiving the segments at all these conditions, I have to do the retransmission in my TCP. Okay. So listen, I think you may kindly note down this one. This is one of the important PPT. Okay, reasons for retransmission. Whatever I told you in my words, this is the reasons, and you all know, see that here, I think you may note down it in your notebooks, a packet. I am receiving my packet. So in this condition, see, from my sender to receiver, my packet have been lost. So you just see, they will keep a timer always to that, whether the packet is received or not. So still the packet is not received, then we have to retransmit that packet. Okay, that's why they have mentioned in the timeout. Or else acknowledgement lost duplicate. Okay, you see that I have received the packet, but I didn't receive the acknowledgement. After delivering the second packet, so acknowledgement is lost. You think that this acknowledgement I have sent for this packet, but it didn't receive to the sender. Okay, when I am seeing that here, so okay, this acknowledgement is not received, so it will send once again. Sometime acknowledgement will lost, and sometime acknowledgement will be duplicated. So these are the reasons I have to retransmit. And then early timeout. Okay, early timeout means this is my packet, but I'm waiting for no longer time that I want to receive the packet. So I'm sending my delayed response. Okay, so delayed acknowledgement. That is also the reasons for retransmission. So the retransmission can be either in the rise of packet lost, or in the acknowledgement lost, or it may be early timeout, duplicate acknowledgement. All these are the duplicate packets. All these are the reasons for the retransmission. Okay. I think now we will see one by one cases. Yeah. How long I have to wait? How long the sender has to wait after sending the packet? How long the sender has to wait? I have to wait for the acknowledgement. Too short should not be there. Too long should not be there. Okay. So too short, wasted retransmission. I waited for some too short of period. Okay, I have to retransmit. At that time also, it's a time period is too short. That should too long. Too long means excessive delay. Excessive delay when packet will be lost. So the timer always has to be fixed properly, where I should not give too short of time as well as too long of time. Once I have log in 9:57, I wait till 10:05, okay, 10:07, okay. After till I am waiting for 10:39, it's not that. But even after 9:57, I started my class by 10, that's also wrong. So too short is also wrong, too long is that. Then TCP sets timeout as a function of RTTT. Actually, we are going to study about this RTTT separately. Actually, not the continuous of all these timer related functions have been seen about in the RTT. So they are saying that how does the sender know the RTT? Okay, you have to estimate the RTT. So you are supposed to know the knowledge of our time, then only we can able to understand that it is too short or too long by deciding by the RTT. What is RTT? It is round trip time. You all understand? You are all speaking. It should not be too short. It should not be too large. And we have to set the timer in terms of time domain. So time domain, we are taking one of the important parameter from that. Sender has to know always the timing. That timing is RTT. RTT means round trip time. Okay, so round trip time, it's a time taken for a signal to send the pulse, the length of time taken for acknowledgement of the signal to be received. I think if I tell it in words, yeah, you all understand. This is my round trip time. Here I am sending my packets. Okay, and this is my packets, and this is my acknowledgement. So this is, they are saying round trip time, RTT. Are you clear? This is RTT. So here, while I'm speaking about my round trip time, the signal sent plus the length of the time it takes from acknowledgement. So data signal transmitted, this is the way they are saying. My packet you have transmitted till I am getting my acknowledgement. So this is called as a RTT, round trip time. Okay, So they are saying the round trip time is 2 into TP. TP is nothing but propagation time. Actually, we were saying the formula directly, but there is a difference on this round trip time. How we have chosen this 2 TP, we will see it there. But you all understand that how long I have to wait, too short or too long, that is not be there. One of the time domain parameter is there, that is round trip time. Okay, so this is the TCP round trip time. So you all see to this, this is one of the important formula. Estimated RTT equal to 1 minus alpha into estimated RTT plus alpha into sample RTT. So they will assume that this is my RTT. You all think that RTT will be in a milliseconds, and in this below the time is there. So sample RTT, and this is all, you know, this blue color is sample RTT and this one is estimated RTT. So we have a sample RTT and estimated RTT, but sometimes you have seen that my sample RTT is higher and my estimated RTT is higher. So we have used this formula to calculate the estimated RTT. So we were saying that sometime it will change and it is depends upon the propagation time. So RTT formula, they are confirming that RTT is equal to 2 into TP. TP is my propagation time period. So from that only we have derived this formula, but it is not completely equal. It is approximately equal. Approximately equal. So estimated, we are not simply saying this is my RTT time period. RTT time period is estimated by using this formula, and sometime that is not very closest to that. At that time, we will see with this 2 time, it should be twice the propagation time. Are you all listening? Students, are you listening?
Yes, ma'am.
Thank you. So here you all seen that now there is a flaw in this approach. We were saying that is, I told you now, my sample RTT is not close to the estimated RTT. Why? Because now you just imagine this is my original transmission, but there is some reasons I have retransmitted the packet. So it will take that RTT time period from here to here. Actually, my RTT is here only. So due to my sample RTT is here only, but it is taking from here to here. So due to this reasons, we were saying that my original retransmission and acknowledgement is there, but due to that, it's not a original transmission. Actually, this is a retransmission. We have to take it. And then one more flaw approach is this is my retransmission here. It's my acknowledgement. So it will take this as a sample RTT. All problem is that sample RTT is not correct in so many times, so that we were saying that the estimated RTT, how we were saying this estimated RTT now, it is not that do not sample RTT when resampling to double time out each retransmission. So all this problem or that is Partridge algorithm is that my retransmission and acknowledgement it is taken, and original transmission and acknowledgement it is not taken. So you are always see to that time period. That is my sample RTT. Sometimes it will be taken as a wrongly. At that time, we can use this formula, the round trip time formula. That is nothing but approximately equal to 2 into TP. So how we were assuming this formula? Na? This is my packet delivery time. Okay, that is propagation time. And then I am having a, so here we were seeing original packet is transmitted and then acknowledgement. That time is my round trip time, RTT. So what is the purpose of RTT now? How long the sender has to wait, whether it is getting acknowledgement or not, that we don't know. Too short, too long, to avoid that we have given a RTT, and sometimes the sample RTT is greater than the estimated RTT due to the problems that it is not computing the original packet transmission and the acknowledgement. Sometimes there is a retransmission period also taken, and then sometimes overlapped signal also taken. So RTT normally the converged formula is 2 times the propagation time. Okay. One more parameter we will say, retransmission timeout. Timeout, we all say the word timeout. When the sender is missing too many acknowledgements and decided to take a timeout and stop sending altogether, that is RTO. RTO occurs, I'm getting too many acknowledgement and RTT is also there. But how come? I just ask you now, students, are you listening? You have unmuted and say yes, ma'am. So that sometimes it is happening. I'm keep on asking you. People are not responding to me now. As a physical mode, I can identify, but in online mode, it's similar to that of how my packet and sender siding is that same to that concept is here. So I'm when the sender is missing too many acknowledgement and decided to take a timeout and stop sending altogether. That means I'm stopping my lecture. Once you respond, then only I can able to continue my. The same thing RTO is that. So this RTO is also be taken, retransmission timeout period also in the sender side. Okay, so what are these common causes for RTO? Duplex mismatch on the switches. You all know my node to node or end to host to host or end to end communication. There is some common causes of RTO. Why? Because duplex mismatch on the switches. You all know from switches we are all transmitting, whether it is bridges will be there, even wireless LAN there is no bridges, the routers will be there, and two different gateway will be there. So that sometimes the duplex mismatch on the switches, bad cable, bad checksums, and driver issue, that are all causes for RTO. RTO is, you all see my packet is, my sender is sending the packet, I'm getting the acknowledgement from the receiver. But you see, I have sent 3 packets or segments. We used to say packets in a transport layer is segments. Okay, so I'm sending my 3 segments, but still I'm not getting acknowledged. So it is give RTO. I give minimum that is retransmission timeout period. Okay, I will wait for the acknowledgement has to come from the receiver, then I can. So it will stop. It will give some time delay. Keep on, I'm talking to you now. You won't understand. So sometime I will stop talking and I will asking whether you listen. The same way the sender is keep on sending the segments. I cannot understand that whether the receiver is on the receiving mode or not. So it will give this RTO, okay, retransmission timeout concept, and then it will wait for the acknowledgement which is received from the receiver side. Then only it will. This is for optimization performance or tuning the network. So for that we can say we have seen sites that show millions of RTOs in 24-hour window. Okay, so with 1 million RTO translating 270 hours of application delay. So we can see to that there is a window. I think if possible I will show it. So just see RTO too large, RTO too small. I think we have seen that here I am retransmitting, but I have kept my RTO is too small. So what happened? I am getting my acknowledgement. Still for that I have retransmitted. So that is RTO, lowered throughput. Okay, RTO too large and RTO too small. So RTO too large in sense, you see, I'm sending my sender. You just look up on this. I'm sending. My acknowledgement is lost. Why? Because now I kept my RTO too large. Slow reaction on losses. Okay, but while I'm C2 here, I'm sending. Okay, but I'm getting acknowledgement. But I kept my RTO too small. So I am unnecessarily retransmitting. So they all told you now that RTO or RTT, that time period has to be always fixed. But due to some reasons, we have seen that a bad gateway or a bad duplex problem on mismatching on the switches. These are the time causes. But without getting the response from the receiver, we have to make that R2 should not be too large and it should not be too small to avoid the 2 reasons. If it is too large, we will send the packet, retransmit the packet. So that is a wastage of the same packet have been delivered for the twice the time. RTO is too small means unnecessary. RTO is too large means that you have to understand that lowered throughput. That means I'm not getting my acknowledgement. So because I kept my RTO So I can fix it here itself. I can fix it here itself or else below that time period. So I gave a long time period. So here RTO too large and here RTO too small. So that's why they told all this RTO must allow enough time, not too large, not too small. So the send TCP segment to transfer the network. Okay. TCP segment to be received and processed by the destination node. Then generation of the acknowledgement of this. Actually, while I'm sending that, for example, this RTO concept and all coming now. One of the thing, ma'am, I think told you for A section, I have told you in B section also. So you all understand, I'm sending my signal. Okay, I'm getting my acknowledgement. Once I get the acknowledgement, so I'm sending first 1000 bytes of data. Okay, so I'm sending 200, some 1000 bytes of data. Okay, so or 100 byte of data, not 1000 bytes, 100 bytes. So next I have sent. So next my acknowledgement number 200 plus 100, 300. So my acknowledgement number should be 301. So what it will do again from 301 to, it will send again 100 bytes. So sometime my receiver buffer cannot able to accept that. Okay, because the receiver buffer is not empty. So what it will do, it will send acknowledgement and it will send the window size is 0. That means it should not send till it getting my window size is 100 bytes. It will wait for that time, then only it will send. So that is the thing. Okay, even my receiver side, I'm having no more capacity to receive the data from the sender. I can acknowledge the signal, but window size I can send with 0. Okay. Yeah. I think some of you have asked that out. Okay. I think this is the normal transmission process. Packet acknowledgement. I have to keep my timeout period. So normal timer, you see 1 plus 5, 6 bytes. So the next acknowledgement number I have sent 6. You see, this is the concept. How the sequence number, you are seeing 1 plus 5, 6. So I am still sent acknowledgement 6. Then it will start the number from 6. Okay, so here when you see, this is 1, 2, 3, 4, 5, 6. So I received my 5 datas. 5 datas get over. This is my 6th. I have to send the 6th. Then it will from 6. So 6 to 10, it will keep on sending. 6 to 10, it will send. Then after 6 plus 10, 16. I have to occupy from my 16 bytes. 6 to 16. So this is this normal acknowledgement and normal timeout period. There is no problem on this case. Okay, it's a normal operation. Okay. Wait, what if the synchronous get lost? Okay, suppose the synchronous packet get lost. Packet is lost inside the network or server reject the packet because the queue is full. That is the reasons. And eventually no synchronized acknowledgement is arrived. Okay, there will be a timer and in that particular timer, I'm not received any acknowledgement. How should the TCP sender set the timer? Okay, how it is sending the timer? Now, sender has no idea how far the receiver is. Hard to guess a reasonable length to time to out. So TCP use a default, that is 3 or 6 seconds. They will use default. Sometime I told you now that estimate sample RTT may be higher than your estimated RTT. But at that time we will say to that my sender has to understand that my packet is lost or not. This is the reason. Sometime it will be internally rejected and sometimes that is no acknowledgement received from that. Why? Because now my receiver side buffer is filled. So at that time or else I have to set the timer. That timer they are saying that the default time they are setting 3 or 6 seconds. I have to wait. This is the reasonable time. Okay, so that is lost due to the, you all know, user clicks on a hypertext link. Sometime the browser create the connect. So at that time, my OS has to transmit the synchronization bit. But you know, still you are uploading, for example, very easily what tab and all we will get it now. When you see our whatever we were accessing Normally, while we are, for example, Satyabama LMS, because we are all keep on doing that. And when you see our Satyabama website and our Gmail accounts and college Gmail ID, why? Because now this is already my OS is in the link. But if I'm searching for any other, now it takes some time. Okay, because there is a time will taken for web downloads. That time it will take 3 or 6 of the time, or else you are not able to. We will reload the page and we will do it. Okay, sometime that won't respond. Now we can come out of that web page and we can go for abort, or else we can give the reconnection to get my hyperlink on the web page. Okay, this is the packet lost. I think I told you that 3 reasons now: packet lost, acknowledgement lost, or some time of duplicated time period, and timeout of packets. So I think the images I have put out for you. So you just see this is the timers. I'm sending. Okay, I think same figure only. Okay, I'm sending from sequence 1 to sequence 5. 1, 2, 3, 4, 5. So this is my sequence 1. Okay, till 5 I'm getting my data. Okay, and I'm telling my receiver is saying that actually I want to send from my sequence number 6. So that's why it is sending acknowledgement 6. So what it is saying, okay, I can understand, I will send from my 6 because it's a byte oriented transmission. So it will say from 6. How many bytes it is sending? 10. So 6 plus 10 till 16. Till 16 it is sending. While send from 6 to 16, 6 to 15. 10 means it will come 6 to 15. Okay, 6 to 15 it is sending, and I have to understand that why, because now includes the 6 also. So totally here I have a 10 bytes. Okay, and here I am having 5 bytes. Okay, here I am having 5 bytes. While I am sending my 16th, I am asking for the acknowledgement from my server, but acknowledgement is lost. Okay, acknowledgement is lost. Now already we received it. You all know already we received it, but it is saying that okay, it have lost the acknowledgement, so it will do this retransmission once again. The problem is here we have acknowledgement not received. Now at that time it's once again we are not using the effective bandwidth of the network is efficiently. So due to that, where acknowledgement lost, once again I'm doing my transition. So this is also the same reasons we were seeing, or with the different images. So 5 segments are there. So you see, I'm getting 4, only 1 acknowledgement for this is missing. So at that time, you see my acknowledgement 2 is missing. So acknowledgement 2 is missing in sense, see you have duplicated the acknowledgement. Why? Because now still the segment 2 is not getting on this time period. So this are all the reasons. Even though I have transmitted the signal, I am in a position of retransmitting of the signal due to this reason. I think actually any one of the figure is enough for you to explain. I think this is well known for you. You are just send this. Acknowledgement lost, duplicate packet, the same concept. Sequence 5, data 5 bytes. Okay, and sequence 6, data 10 bytes. So this is the acknowledgement for this, and this is the acknowledgement for this. Okay, and you all seen again I am sending, see, this is the acknowledgement. Why? Because now my timer is here. You see, this is my timer sequence 1, and this is my new timer sequence 1. So even though I have transmitted, I am not received in a particular time period. I am retransmitting. But you have seen, I have received this before the time ends. I will. That's why I told you now. Even though that RTO is too small, at that time also the retransmission cases will come. This is one of the cases of that. So they were saying that even lost segment, not only from that, we are all speaking from the acknowledgement, it's not received from the receiver side, but it will also come from the sender side also. You see, this is the receiving buffer. You all understand? This is my 501 to 600 I have received. Once again. So when you see to that, my 501 to 600 and this is 601 to 700. So you see that my 701 to 800, I have lost. So you see this particular data will not be filled. So that is the last segment. So then what happened out of order 801 to 900. But you see, this is coming, but I didn't receive the acknowledgement for the 700. So there is a mismatch. So the timeout is that. So I not received my proper. So first I have to fill my 701 to 800. Then only I have to fill my 801 to 900. So there is a gap on filling the 701 to 800. Why? Because now I didn't receive the acknowledgement properly. Why? My packet have been lost here or my segment have been lost here. So once it is received the acknowledgement, then automatically it receives out. Why? Because now RTO, because I due to some concept retransmission timeout period is occur. So due to that timeout period, once again I am resending my retransmission of my packets or segments. Okay, I think these are all about this same concept only. We have seen all this retransmission. One more concept, fast retransmission. Okay, we are slowly retransmitting now. To avoid that, sender retransmit the data after the triple duplicate of acknowledgement. We have to do the fast transmission. Why? Because now, when does the fast retransmit work now? Long data transfer. For example, I'm using 4 gigabytes links instead of 10 Mbps links and high window size. My receiver can accommodate high window size in my receiver side and low burstiness in packet losses. There is low traffic or congestion control or implications of web traffic. All this concepts I can do my fast retransmission. Transmission, they are saying you're keeping timeout period and RTT, everything is there. But to avoid all this kind, I have to do my fast retransmission at some, not in all circumstances, whether I can do long 4 gigabyte per link I am having, not in the case of 10 Mbps link, high window size I'm having, and low traffic problem I'm having. I can go for fast transmission. So I think this is the fast retransmission concept. So you see to that when I'm receiving here 101 to 200 I'm receiving. Okay, and here I'm receiving for 201. Okay, 201. Okay, once 201 I have received, the next one I have to receive 301. But you see my 301 signal is lost here. Okay, once 301 is lost, I will automatically send 401. Okay, and then I'm sending, keep on acknowledge. I'm sending 301, 301, 301. So it will wait for 3 acknowledgements. That's they are saying triple acknowledgement, 3 acknowledgements. It will wait. Okay, it is saying that this 301 is not. It will be we have seen one of the important work of this TCP layer. Hello, how are you? That is the concept I told you. Hello, how are you? I received hello. Hello, how are you? I'm sending from my sender side. I'm getting my hello. You or I'm getting, but I'm not getting how. So it is all reassembled. Okay, so I am waiting for 3 acknowledgements. Still my 301 is not received. So what I will do, I will first fill this 301. Then for waiting for 3 acknowledgement, I keep on getting my data. It will be reordered. Then once it is 301 is ready, it will do the reassemble, and that is the fast transmission. So doing my long transmitting and my receiver buffer is full. Receiver buffer can accommodate. I can go with 3 acknowledgement, and after the 3 acknowledgement, I can get my 301 packet resent from the sender side, and I can do my reassemble, because reassembling is one of the important work of transport layer. Transport layer, we have seen so many work identifying the surface, whether it is a TCP or UDP. It will do reassembling, it will do multiplexing, it will do demultiplexing, it will do the error control, it will do the flow control, it will assign the port address. The similar way, the next one is it can do the fast retransmission. So when my acknowledgement is lost, or packet is lost, or timeout period is expired, All the time I will do the transmission, but this is another more of the transmission, that is fast retransmission. I can wait for some 3 more acknowledgements till I can understand that I'm getting 3 acknowledgements, so I have to send that packet immediately. So that packet will be immediately resent. Yes, have you understand? Yes, students, have you understand? Students? Students? Have you understand, ma?
Yes,
Alin?
ma'am.
Yeah.
Yes, ma'am.
Yeah. This is the assignment I have given for you. I think this time the assignment is somewhat tough for you. Okay, I think I will tell you the first 5 questions are very easy for you. Okay, differentiate between connection oriented and connectionless and the connection oriented principle. Okay, I think we have a small recap on this. Today I will upload till this PPT also. I will upload the flow control and as well as a retransmission PPT here. You may look up on this, and this particular class also will be uploaded there. Okay, actually one question I have asked, why is UDP pseudo header included in UDP checksum calculation? What is the effect of invalid checksum at the receiving UDP? So you all understand this is the UDP format we have taught you in the class. Okay, it is a 8 bytes, source port 2 byte, destination byte 2 byte, and total length 2 byte, checksum 2 byte. So totally 8 bytes header will be there. Okay, so when I'm seeing my pseudo header, we all know that IP address also sent along with the this UDP header. So that will be the pseudo. Okay, so how it is checking the checksum calculation, I will tell you. So this is my pseudo header. So you see that 4 byte, and 2 6 byte, 8 byte will be for my IP pseudo header, and 4 byte for my UDP header. Okay, you just see how it is doing the checksum. We all know that while speaking about UDP, we used to mention that it is a connectionless protocol. It won't check for flow error. It won't check for the error control, flow control, nothing it will do. So while I want to send any multimedia files, I always prefer this UDP and the user datagram protocol I will send, and the packets in the UDP will be called as a datagram. That and all we'll see. But we have one bit in the UDP, that is checksum bit, checksum. Okay, how it is doing this checksum? This is the example I have carried out for you. You just see, this is my 32-bit IP address. This is my 32-bit destination address. Okay, and this is my all zeros, 8-bit protocol number, and this is my 16-bit UDP total length. Okay, and you all know this is my port number of my source site, and this is my destination number of my port site, and this is my UDP total length, and this is my checksum. I am saying that checksums are all zeros. Okay, but you see that how it is doing that checksum. Now you see that I am adding each and every. This is one 8-bit and this is the 8-bit. So you see to that 153.18. You all know I am just converting this 153 into binary. We all know depending upon our page, 2 power 0 plus 2 power 2 power 3, 2 power 4 and 2 power 7, I will get 153. So this is the way you all say I'm sending testing. This is my data. So there also I am putting T and E and D. But you all know my checksum, my sum is this. We all know the checksum, what we will do. In checksum, what we will do, ma? Sum will be there. In checksum, how will you find out checksum? Anyone have a remembrance on that? We have done in the data link layer, doing error handling function. Anyone remember? Yeah, I'm getting over chat. One's complement, Soumyadi, very good. Yeah, one's complement. Very good, very good. So we will take the one's complement. So this is my sum and this is my checksum. But in checksum, So you see to that while I want to do the checksum. So how it is performing the checksum? There we check with the data, but that's why I gave you this question, but you have to know how you have to understand in your point of view. Now that's why I given this. So I think I will upload this PPT also. You give the correct answer for my question. Is clear? Okay, this is that. And I think ma'am told you about the silly window syndrome, Nagel's and the Clark solution and all. Okay, so one more example. Okay, I think one more question in my thing is about this calculation, 9th and 10th. What is the need for Nagel's algorithm? How it is determined that that's why I gave this silly window syndrome problem, waiting for too many acknowledgement. It's not everything. So these are the reasons I gave you. You may refer it and you give me the answer for this question. Okay, it's a completely theoretical part. So here, how it is sending, actually for your purpose, I have explained you. I'm sending 100 words. Okay, average words a minute, and each word has an average of 6 characters. Okay, so you just imagine 600 characters. Okay, and 100 words now, each word having 600 characters. 100 into 6, 600 characters. Okay, 600 characters I'm transferring in 1 minute. Okay, and you all know that RTT, I'm telling that it all happen in 20 milliseconds. I'm keep on calculating my time period. How many character I'm sending now? 0.2 character. Is there any use of sending 0.2 character? Because I have to send at least 1 character. You all know I'm having my TCP header length is 20 bytes. Okay, my IT header is 20 bytes, and totally 40 bytes, and sending 1 bytes now, it is completely waste. Okay, so to that, but you see here you are sending 0.2 character. So that's why while we are speaking about this, this is the way they will calculate the time period. And one more example also that. Sequence number, that is all you know. It is for security risk. These are when INSNs are predictable, it will become security issues. So for that, it won't always starts from 0. Okay, I think this is a one best example. How the sequence number denotes the number of bytes of data to 10. For example, my sequence number is 32 bit. Now, 2 power 32 bit of data I can send. That is nothing but 4 GB. You can just put out this 2 power 32 equal to 4 GB. So this is my sequence number. It decides the capacity of data. So I am saying 1000 bytes of data I am sending. Okay, or else very simply I am sending 255 bytes of data. 255 means we all know FF. Okay, so FF means 2 power 8. This is the way they will calculate. Okay, powers of 2 only they will calculate the data. Just you see how time period they have calculated. I will tell you how to calculate. Please kindly note down this, how it is calculated. 1 GPS link if you are having. Okay, what will be the TCP sequence to wrap around completely? Okay, you just see minimum. Actually, my TCP size is 20 bytes to 60 bytes. We will take 20 plus 20, 40 bytes. Okay. Okay, 40 bytes. Minimum packet size, we always kept 40 bytes. So 40 bytes now, while I'm calculating 40 into 8. Okay, 40 bytes. 40 into 8 now, 320 bits. Okay, so you all understand that I'm taking 1 Gbps, my TCP 2 power 32. It is because gigabit definitely. So the maximum sequence number is 32 bit only. So I can use 2 power 32. Okay, maximum sequence number. While you go and check in your TCP header, there you have a sequence number bit. So 2 power 32 into how many packets more? 40 bytes into 320 bits per packet. So I will get how many bits now? 1.4 into 10 power 12 bits. 1.54 into 10 power 12 bits. So 1.4 into 10 power now, how my link is what? 1 Gbps. 1 Gbps now 1.4 into 10 power 12 divided by 1 into 10 power 9 bits per second. So I will get 14000. Okay, 1400 seconds. It's nothing but 23 minutes. This is the TCP wraparound time period. How I am calculating my time period. That's why if I show you a previous, have you understand this? Have you understand? 2 power 32 bit is my highest sequence number into 320 bits. So I can transfer 1.4 10 power 12 bits. That you can fix it. Then this speed will be vary. This is always, this value will be the same value. But my speed, I am saying 1 gigabits per link. So 10 power 9. Yes, are you clear? You just see 1.5 Mbps. So when I am taking that 1.4 10 power 12 divided by 1.5 Mbps. Mbps now we all know 10 power 3. Sorry, 10 power 6. And you all know Ethernet 10 Mbps. T3 45 Mbps. If our fast, so we have to see that how long, when you see that while I'm moving from gigabits per second to megabits per second, it takes the time till wraparound. Sometimes you are uploading in your drive and all, it will say 2 hours, 7 hours, 8 hours. Why? Because now that time until the wraparound period, how far the network faster, because it will keep on changing. While we check our internet speed, my time period will keep on changing. That's why it will vary from this much to this much. And while I'm going with 1 Gbps for my data now, obviously it takes 23 minutes. Have you understand one of the question I have asked in the assignment? Same question is for 10 gigabits per link. Yeah, this question is like that. Suppose TCP operates 10 gigabits per link. How long it take for a TCP sequence to wrap around completely? So we will say that I will take my sequence number as 32. But in this question, you have to find out the sequence number. What will be the sequence number? Actually, that is also I have given here. Okay, you just see this problem. Another 5 more minutes, 3 more minutes. Yeah, you just see you are hired to design a byte stream protocol using a slide window, and this protocol will run over 100 Mbps network. The RTT of the network is 100 millisecond, and maximum segment life is 60 seconds. Okay, RTO, we all know that RTT, that time will be 100 now. Then maximum segment life is 60 seconds, 1 minute we are doing. So how many bit you will include in the advertised window and the sequence number field of your protocol header. Okay, so you have to design your own TCP header now. How they are doing, what is the calculation behind this now? First, you have to see that my millisecond, you all know this is 100 Mbps. Okay, we have to decide the bandwidth of the time period. So per second, 100 megabit per second. Into I have to definitely multiply with the bandwidth. If I want to calculate, I have to be in the bits. So I am multiplying with 100 millisecond. So into 10 power minus 3, I am multiplying. I am getting 10 MB. 10 MB. You just see, that is my bandwidth. So if I convert my bandwidth to bytes, you all know it is a 10 MB now. 10 MB, 1 byte divided by 8 now, 1.25 MB. Okay, 1.25 megabit. That means what will be my addressing now? You all know 2 power 16. What is the answer now? 64 KB. I think you have studied so many places. Okay, 2 power 16. Its capacity is 65,535. So 64 KB. 2 power 20 now 1 MB, 1 megabyte. Okay. So 2 power 21 now, obviously it is 1.25 Mbp, 1.25 megabit. Why? Because now you all understand this is calculated from this powers of 2. You see 2 power 16, I told you na 65,536. 2 power 20, 1 megabyte, and 2 power 21. Okay, 2 MB. So they were not 2 MB. It is between it is greater than 1 MB and less than 2 MB. So that's why I choose 2 power 21. So the sequence number should be 2 power 21. And we told you that the maximum segment lifetime is 60 seconds. So they were saying that in 60 seconds, you all know the 10 MB data, na, 6000 MB of data will be sent. Okay. So to that, while I'm doing that 6000 MB into that 6000 divided by 40, if I calculate 150 million, okay, how I'm getting this 60 MB, 6000 by 4 or 40. If I calculate, then automatically I will get 150 million medium sized data. So 150 million means again I have to check with that. My advertiser window here will be 21. Again, you go and check that 150 million in the Google. When you see to that, it is around 2 power. It is between this 134 million to 268 million. So definitely my window size will be 27 to 28. So maximum we will say 28. Okay. So that is the way they were identifying the size of the sequence number. Okay. And I think only 1 minute for me. Okay. I gave you this problem. Sagar, you have solved. But you all know here, this particular problem, I will say, me and ma'am have taken for you in the class. Okay, so we have told you the several times, it's one of the important, even though it is a 4th unit assignment, but this one single problem we have asked in 3rd unit, you can't get it in the net. You refer your class notes only, it will help you. So Sagar, you did this correct, but in your neighbor, you have done a wrong thing. Okay, BA, because here I didn't give the network ID separately. So network as well as my neighbor, both will be same only. Okay, after that you have to converge it. This I didn't check it, but this is a small correction. Students, first you write the link state table, then you start from the least cost. But you have to do for which table? Na C. You have to do it for C routing table. Okay. So I think you may solve it and you do it. Till this, I will upload this PPT for your reference. Is clear, ma? Ma'am, solunga ma'am.